Okay, so today we will do lesson 7.4. We did 7.1 and 7.3 already. So 7.4 is over more properties of logarithms, and we started logs in 7.3. So I'll go ahead and let you see my screen here. Okay. So in 7.3, we learned this property of logarithms. If you have a log base b of x equal to some value, then it can be rewritten in exponential form where it's x equals b to that value, which is question mark. So it's like just rearrange the x, b, and the question mark. So the b goes from being the base of your logarithm to the base of your exponential. The question mark value ends up becoming the power, and then the argument goes on the side by itself, so the argument is x. So I put a star by it last time, so just so you know that's important, and it's something you'll have to know how to work with and have in your mind of the fact that these things can be written interchangeably. So if you start with the log side, you can go to the exponential, or if you started with the exponential, you can go back to the log, whichever one happens to be more useful at the time. But in this section, we're going to be going over more properties that logarithms have, and specifically expanding and contracting logarithms. Okay, so these three properties. The first one is the product sum property. So if we have log base a, so base, it could be any base there, of x times y. So if you have two things multiplied together on the inside of the logarithm, you can write it as two separate logarithms. Log base a of x plus log base a of y. So it goes from being multiplied on the inside to being added together individually. Okay. The second one is similar. Instead of having two things multiplied together on the inside, there'll be two things being divided by each other, so x over y. So I may have said before that multiplication and division are like twins, and then addition and subtraction are also like twins. So if two things being multiplied together turns into addition, then it makes perfect sense that two things being divided by each other would turn into subtraction. So this is log base a of x minus log base a of y. So whatever is in the bottom of the fraction, or the thing that you were dividing by, it becomes subtracted instead of added. And then the last property, then log base a, if you have something in the argument that is something to a power, so I'm going to write x to the r. A way that you can write that is we bring the power out front as a coefficient, and so it becomes r times log base a of x. So it goes from being a power on the inside to being a coefficient on the outside. Okay, so those are the three properties, and we'll be using those in the examples today. So here I actually have this written incorrectly. Instead of starting on the right and changing to the left, we're going to start on the left and change to the right. So if we start with something that's on the left side of one of these three properties, so start with either something that looks like one of these three, and then we move over to the right, like adding, subtracting, or moving out as a coefficient, then that is called expanding, because we're making it bigger, making it into more logarithms instead of just one. And then in this one, it would be it comes out as a coefficient. So instead of having everything on the inside of the log, you have something on the outside here. So we call that expanding the expression. And so with expansion, it usually starts out as one single logarithm and then breaks up into multiple logarithms. And instead of having the exponents in there, it has coefficients out front. So it changes into multiple logs. And then the power, or the exponent of each argument, is 1, or I'm going to write degree there. So this one should not have, if you've expanded something, there should be nothing like log with power on the inside, nothing like that. The power would come out front. And then same thing, you shouldn't have the log of two things multiplied together. Like you wouldn't have log of 3x. Instead, you would write log of 3 plus log of x. So it's expanded as much as possible if it has to expand. Okay. So similarly, if we go the other way, and I'm going to correct my notes there, should start on the right and go to the left. So if we start with one of these expanded ones here on the right, and then we move over to the left and put it all as one logarithm, we call that contracting. So instead of multiple logarithms, we put them all as a single logarithm, just one. And then the coefficient, or the number out front, is 1. So nothing like a 3 in front of the log. That would turn into log, they say, of x to the third. And you wouldn't have multiple logs. Like if you had two logs being added together, you would switch them into one log with two things multiplied on the inside. So first, it's asking us with these questions to expand. And so that's what we'll do with all of these, is expand the expressions, and then we're going to do several where we contract it. So with the expansion, the first thing you should notice about this first example is that it's a fraction. So we have two things being divided by each other. And so we can go ahead and use the second property there. I'm just going to write a little 2 above it. You don't have to write that 2, I'm just writing it so you can see what I'm doing. The second property, which is the division, to say that this is ln of 12x squared minus ln of y to the 9th. Okay, so we've expanded a little bit, but it can be expanded a little bit further. If we notice with this one, we have two things both being multiplied together. We have 12 and x squared. So those can be split apart also. And so two things being multiplied together, we write as two separate logarithms being added. So ln of 12 plus ln of x squared minus ln of y to the 9th. And what we used is the first property there, where we go from addition, or we go from multiplication to addition. Okay? And now the last thing we want to notice is that we have some powers out here. Well, when we expand, we don't want the powers on the inside, we want coefficients on the outside. So both of these, we can use that third property to get those expanded. So I'm going to write 3 there. So it becomes ln of 12, or natural log of 12, plus 2 natural log of x, and might write it in cursive so it doesn't look like a 21 actually. And then minus 9 ln of y. Okay. And so now we look on the inside of our logs, and we don't have anything being multiplied together. We don't have anything with exponents, and so that should be expanded as much as possible. And this should be our final answer. Okay. So next, we will expand number 2. So number 2 doesn't immediately jump out that it can be expanded very much, but we can rewrite it as 2 things being multiplied together by factoring out something from these terms. So if we look at 20x and 12y, we notice that 20x and 12y can both be divided by 4. So we can pull a 4 out of both of those terms. So I'm going to keep log base 4 out here. And then I'm going to write 4 and basically pull it out like the opposite of distributing. So 20x divided by 4 becomes 5x, and 12x divided by 4 becomes 3y. So we pulled that 4 out, and now we have 2 things being multiplied together. We have 4 times 5x plus 3y in the inside of our logarithm. And so we can use the first property to split that up into 2 separate logs. So we're doing log base 4 of 4 plus log base 4 of 5x plus 3y. Okay. So now I think that is expanded as much as possible, but it's not really in the simplest form that it could be in. Because this log base 4 of 4, we can write that as just a number. If you remember from the last lesson, if we have log base a of a, the answer just ends up being 1. And so log base 4 of 4 is equal to 1. And then we just keep that other log added. So log base 4 of 5x plus 3y. That should be our final answer for number 2. Okay, so now we'll move on to number 3. Yet again, it doesn't immediately jump out that you can expand that, but it is something that can be factored on the inside. So we will factor that. So we've got the natural log, ln, and then the inside here, we're going to factor it. So the first thing that we can do is we can notice that each one of these terms can be divided by 8. So I'm going to pull out an 8 out front and factor that 8 out, like the opposite of distributing. So 8x squared divided by 8 is just x squared. Negative 72x divided by 8 is negative 8x. Wait, sorry, negative 9x. And then 112 divided by 8 is 14. Okay. And now this part can be factored a little bit further. So natural log, we're keeping that 8 on the outside, and now I'm going to factor this quadratic here. So x squared can be split into x and x. 14 is 2 times 7. And then we want a negative 9 in the middle and a positive 14 on the end. So they have to multiply together to get negative 9, or sorry, add together to get negative 9x and multiply together to get positive 14. So it works if we do a negative 2 and a negative 7. Because negative 2 times negative 7 is negative 2 plus negative 7 is negative 9, and then negative 2 times negative 7 is positive 14. So now we have the natural log of, instead of two things multiplied together, we actually have 3 things being multiplied together. But this concept is exactly the same. So if we go from the natural log of 2 things being multiplied together, we can write it as 2 natural logs being added. So same thing if we go with 3 things being multiplied together on the inside, we can write as 3 separate logs that are all added up. So ln of 8 plus ln of x minus 2 plus ln of x minus 7. So it works if you have 3 things on the inside, or 4, or however many you have on the inside of your logarithm. You can still write it as however many logarithms being added together instead of 1 logarithm with everything multiplied on the inside. And that is the final answer for number 3. Okay. So those are all the examples of expanding logarithms. And so now we're going to contract or condense them. Okay. So with condensing, we're going from multiple logarithms, all putting them together into 1 logarithm, and instead of any coefficient from the outside, they should be powers on the inside. So if we go up to the 3 properties, it would be moving from this side over to this side. So going from the bigger expanded one into the smaller contracted one. Okay. So with the first one, we have 2 logs being added together. And so that is property number 1, which means we can write it as a single logarithm. And instead of addition on the inside, we're going to have multiplication. So we multiply z and 19. We'll get 19z. And so you notice we have 1 logarithm, and there's no coefficient out front, or if there was a coefficient out front, it would just be 1. And so this is actually just a 1-step problem. It's already in its most condensed form. And so now number 5, we have subtraction. So if we have 2 logarithms being subtracted, we can write it as 1 logarithm with division going on the inside. So it needs to be log. And just as a note, since these logs don't have a base down here, we remember that that's base 10. Just, I don't think it really affects this problem, just other than the fact that we just, need to know what the base is anyway. But we have log, and then on the inside, we want z over 18. So just one thing to be careful of, make sure you do not write 18 over z, because that is a different problem. You want whatever is being subtracted to be the thing that becomes divided, and if there's something like if it's added, it can go in the top of the fraction. So just careful that you do it in the correct order. And that would be from property number 2. All right, that is as condensed as we're going to get it. So we can go on to number 6. All right, so with number 6, we have several things going on. We have these coefficients out front, we have addition, and we have subtraction. So what we need to do, we can't really add these up yet because that 5 is in the way. Same thing, we couldn't subtract those because the 5 and the 7 are in the way. So what we first need to do is that 5 and that 7 need to go into the inside of the logarithms as exponents before we can do anything else. So we're going to use the third property first. We'll get natural log of 3. And then the 5 ln of x, The 5, instead of being written on the outside, can go on the inside as x to the power of 5. Okay, same thing here. We have 7 ln of y, so we will subtract. And instead of 7 on the outside, it's going to become the exponent of y. So minus ln of y to the 7th. All right. So now we don't have any coefficients, which is good. And so now we can work on putting them all into a single logarithm. So I'm going to do these first two first, and then I'm going to do this last one after that. So the first two, since they're being added together, we can use the first property to write them as one logarithm. And then on the inside, there should be multiplication. So 3 times x to the 5th. And then this one is just going to hang out. ln of y to the 7th. Okay. So now we have 2 logarithms being subtracted. And so we can write it as a single logarithm with division on the inside. And that is going to be the second property. So 3x to the 5th over y to the 7th. And so now you see this is written as one logarithm. There's no coefficient out front. And so that is in its most condensed form. So that is our final answer. Okay. So now number 7, I believe that, yes, that's our last one. We have log base 4 of x squared plus 10x plus 16 minus log base 4 of x plus 8. So we don't have any coefficients out front of either the logarithm, so we don't have to worry about the third property. All we really have is this subtraction so far. So we can write it as a single logarithm, log base 4. And then we can write a division on the inside. X squared plus 10x plus 16 over x plus 8. So it is contracted as much as possible because there's no coefficient out front and it's all as a single logarithm, but it is not in simplified form. If we want to check that and make sure that we're in simplified form, we need to factor the top part of this and see if it cancels with the bottom part. So I'm going to go ahead and factor the top of that fraction. And the bottom doesn't factor since it's just a degree 1 on the bottom. So on the top, x squared becomes x and x. Our factors of 16, it could be 4 and 4, but 4 and 4 is never going to make a 10x. So we can also think of it as 2 and 8. 2 and 8 can make 10, so we're going to go with that, 2 and 8. We need a positive 10x and a positive 16, so they have to multiply together to get positive 16 and add together to get positive 10. So if we put plus 2 and plus 8, that gives us what we need, and that's the factored form of that numerator. So now we notice we have x plus 8 in the top, x plus 8 in the bottom, and so that should be able to, since we're dividing those by each other, they should cancel out. And we are left with log base 4 of x plus 2. And that ends up being the final answer. Okay. So that is the last problem of this section. So if you have any questions, feel free to email your teacher or log into the Zoom sessions and let us know. All right.